Alright guys, welcome back. Today's little video is an exercise. Rumor has it that dial indicators aren't that accurate, that I should be checking them all out. So I did a lot of flailing around at first, so this became very educational for me. So first of all, I had to back all the way up to square one. So here's square one. All right, I had, come on, get this out of the way. I had to back up on this because I'm thinking, how can you check the accuracy of an indicator when you don't know what the size is of what you're measuring? So, all this certificate stuff, who knows? So what I did was I wrote down some sizes that I'll be testing. Basically start at 100,000th increment by 100. So 100, 2, 3, 400, 500, 600. Now, I look at their certificate of calibration and traceability. And according to grade B, these deviations should be increments of a half of a tenth of a thousandth of an inch. So I wrote down, I look at it, okay, it says 0.1 is up 11. So 11 times a half a tenth, and it should be 0.1055. So I do the math on all of them, and the half inch was crazy because it came in up 21. So the half inch should be 0.50105. That's up a thousandth. So in any case, I write down what the certificate says these blocks actually are. Grade B, grade A as 2. All right. The inscriptions say workshop grade for precise measurements. So I take my stand so I know that I can easily turn, I'm not angling things, messing things up. I take the good expensive Mitutoyo, which you look at the specs on it and it says it's good to a half a tenth. It doesn't say plus or minus, it just says tolerance half a tenth, and it even says it right here. So you mount this guy up, and then I start with the 100,000th block. And you carefully degrease, wipe, double check, and it says it's supposed to be 0.0055. I'm coming up with 0.0015. So maybe something's wrong with the math and the increments are wrong. So what I did was I took the worst one, the half incher, and you take what I'm actually measuring, and I divide that by what they're saying it was, up 21, and you come up with, okay, maybe that's the real plus or minus increment on it. No, it doesn't add up with what I'm measuring. So I go through all the blocks, and the curious one is the half inch was supposed to be a thousandth up, and I'm coming up with 2.5 tenths up. So, okay, now I've measured them all. Now I take the other caliper, micrometer, and I didn't look it up, but it says right here it's good to a tenth of a thousandth. Put it in the holder, carefully measure all these blocks. The 0.1 is supposed to be up a tenth and a half, according to him. You can kind of judge on this guy with a magnifying glass that it's in that ballpark is what it's measuring. So I go through all of them. Now the interesting one is the 3/10 says I'm supposed to be 7/10 up according to the certification. With this guy I'm measuring 2/10 up. With this guy you can easily see it's 2/10 up, not 7/10. You would easily see a 7/10 on this thing, at least a half a tenth. What am I going to say here? Yeah, that's a half a thou. So yeah, you can see it. Well, I could. So now I know what the actual size is of these gauge blocks. And I started thinking about this certificate going, you know, you try to picture the production line. There's a guy sitting there, got to have a computer, I'm sure, which is ready to print this out. Oh, and I did verify the serial numbers, they're all correct. But he's going to print this out, and so he's got gauge blocks. Are they coming at him in order? Because in random, he would have to go, okay, this is the 0.1007, let me enter in the serial number, and then how's he doing the deviation? Is he punching into some machine? This is a 1007, puts the block in there, and then it says, oh, you're off by 8. I don't know. But I can see this being a very labor-intensive, boring job where he's just starting to make up numbers. Oh, here comes the boss. Let me actually measure one. I don't know. But this certificate's completely bogus on every one of these. What is that? That's six of them. I actually didn't measure the 750 because it's the only one in here that says it's correct. Deviation 0. I should go and measure it. So at least I have some blocks now that I know what the size is. So now I can start playing. I need to find still a more stable setup to be able to measure that down into tenths without the arm flexing on it. So let me see what I can find and move on. Interesting. For a grade whatever gauge block set, they're not even close or whatever. So now it's a matter of, I did some testing on the granite plate, granite surface, and so I started investigating my Noga holder, and this is basically what I found. Okay, I've got this set up for a reason, to try to show how the whole, you cannot measure things to a tenth of a thousandth with this type of setup. I can't get in front of the camera, so the camera is in direct alignment with the gauges. I'm holding a piece of plastic here trying to keep the reflections down, and I hope I'm close enough that you guys can see the needles. Raise it a little bit, but wherever the Fowler gauge is, if it's on 0, I don't know. I can't tell right now. But the point is, that's a 600,000th gauge block. Oh, I gotta drop this thing. I can't. Can I do this? Yay, it stays put. I've got it propped up against the light. So if I raise this up, the spring pressure on a 600,000th block is going to push this entire arm up, so you're going to see this move. So here we go. There. So the 600,000th is supposed to be a tenth high. You don't see it here because this moved. The entire arm moved. So I have ordered a more stable setup here that I can actually now, hopefully I'll have to check the new setup, but I'll see how stable it is to be able to measure to a tenth of a thousandth. So as far as dial indicators, if you want to try to measure tenths of a thou, even 1 thou, it depends on what you put under here. And the reason is this, you can see I just slightly get my hand out of the camera, but you just slightly push on this thing and you can get easy movement on it. So I mean, this is a Noga arm. This is pretty much as solid as I can get. But if you're going to measure a 1/2 inch, you're going to be, the force of this spring is going to raise the arm up. So this is a 0.5 gauge block, which is actually 0.50025. But again, it looks like it's 0.5 on the money because the arm's getting pushed up 2/10. If you do something low profile, let's put in, here's a 0.10055 block. So it's pretty low. The spring tension is very low. So you should be able to see the half tenth. And there it is. It's actually lower than it should be, but then again, see, I just rock it, and there's play in the rack and pinion in this guy, which throws it off. But I heard that all dial indicators are only accurate to plus or minus 2,000. I've searched, and I've only found one dial indicator that actually gave an accuracy specification to it, and yeah, it was 2,000 plus or minus, but I couldn't find any other ones. I've got 3 dial indicators. I've tested them all, and they're pretty much so responding exactly like this one. This, if you look at the face, doesn't have a model number on it. You go to the Fowler site and you check any of their dial indicators, and none of them I've found have a specification or an accuracy spec listed. Let's try a tenth here. Let's go to, this is a 0.1 block, which is actually 0.10015. So you might be able to see the tenth on this. Let's see. Boy, is that a push. It's just slightly up, but I need the magnifying glass to be able to tell myself. And again, you can just move this. Looks like it's going down to 0. So, I mean, these things are pretty accurate, but anytime you really want to measure something, you use a mic or an expensive digital mic. I've never seen videos where professionals, real machinists, are using a dial indicator to measure anything. So this is my opinion on dial indicators from my experience and the 3 indicators I have. Okay, this is the shorter Turlin one, which is a 1/2 incher. And it's a lot less force on this guy to pick up. So this is the 0.1 block, which is 0.1055. So this is a, what is that? Yeah, 1/2 thou up. So if I get him under there, so he kind of shows it, huh? Yeah, you can move it around a little bit. Can't tell without my glasses, but so yeah, it's 5 is a 1/2 thou. All right, so he's pretty good there. Let's take it to 0.2, which is here, which is 0.20015. All right, try to scooch it around a bit. Eesh, the whole thing moves. Yeah, it's not showing a 1.5. Looks like it's right on just 0.2. But, so these guys are, can I do a 0.3? That's pushing it. Let's try 0.3. I can't make it, no. Don't have enough of distance. But this guy's pretty good too. All right, hindsight, you always sit back and think about this stuff. And I had bought the digital guy for reflections and getting rid of parallax and so on, and discovered that it's real touchy because of the sensitivity of it, the resolution. So, playing with the different holder, realizing I'm not going to be able to use this guy unless I buy the comparator stand. So in hindsight, I would never have bought that had I not have bought this guy. So this is kind of writing this off as an educational expense. Glad I did. This guy's a blast. So coming up, the stand came in. Thank you, Anytime Tools. Incredible stand, which you'll see. And then after the opening of this guy, receiving it, you'll see a bunch of different little clips playing around with the different indicators and so on. And then at the end, just kind of a little bit of a summary to it. So I hope this helps somebody out, and I'll see you next Friday. Comparator stand. I was looking at all of them on eBay, and got Mitutoyos and this and that. So I figure, you know, Anytime Tools, they've never let me down, so just order theirs. This was like $60, $59.95 or something. Where did they seal it here? Can't tell. Rip. Ow! And it is heavy, yep. So, let's see what happens here. Box in a box, huh? Ah! Boy, this sucker is indeed. Oh, nice, huh? Wow, airbags that survived that? I'm impressed. Okay. UPS label. This came regular postal service. Okay. Come on, Anytime. Don't let me down again. I mean, not again, but they haven't yet. So this should be really nice, I'm sure. And nice heavy-duty hardware. Oh, look at the nice size of that. Ow! This must be the granite block. Oh, this looks sweet. And nice, yes. A little bit of oil to clean that up. But that's not going to bend. That looks really nice finish. They give you the bolt and the wrenches too. Think, what's the small wrench for? I don't know. But yeah, they had the specs on the site too, of flatness, and nobody else had specs, which was like, huh? How do you expect to sell it when you have no specs? Well, heavy duty. Okay, it opens this way. Nice box. Oh, look at that. What's it say? Granite comparator. Grade A. Ooh, really? A? Can't get it out. There. Oh, nice. Look at this. Perfect stand. All right. See? Anytime Tools. Thank you again. Great. Oh, this is what I did with the rod. Okay, so I just need to put this thing together, clean it up a little bit. Here's the hardware for it. With a fine adjust. Wow. Metal flyweight, but metal. Yeah, interesting. Got to figure out how this thing works. Okay, let me put it together and clean it up. Anytime Tools, great stuff. And on eBay, they're called Anytime Parts. I don't know why, but so to do this, I don't want to be taking these studs out all the time, and especially the digital guy doesn't have. Well, actually, I might as well change the back. But I was thinking, just get rid of this lower part here, and then make a piece that just this bolts to the bottom of this thing, and just drop the indicator in the hole and a little screw or something to lock it down. Oof, I don't want to make marks on this thing, but so I guess I'll set this up and try it with the digital. But geez, this is really nice. I mean, rock solid. This is not moving anywhere. So well worth the money. Let me set it up for the digital guy. Well, I'll tell you, this is going to be a joy to use. I already played with it a little bit, but it doesn't appear to be bending. Look at this. Like right there. Let's see if I can zero it. I mean, to begin with, it's touchy, but all right, so I got it zeroed out. Let's see with something rock solid how these blocks come in. 0.1, where are you? 0.1 is a 0.1004. And as this microphone cord falls around, So 1004. Yeah, the last one should light up. Nice smooth surface, I'll tell you that. Yep. So indicator is off, huh? Wow, by quite a bit. Yeah, up one. Oh, I grabbed the wrong one. That's 0.10015. Where's the 2? Alright, so 0.2 is 20015 also. So, alright, why are you reading up with thou? Try zeroing it again. Yeah, it zeroes right out. It's way different than trying to do it in the Noga arm. Yep, down quite a bit. So not that accurate here, it would appear. It's reading consistently low. 0.2. 0.3 is 0.3002. Where is 3? Here it is. 0.3002. Yeah, it's reading quite a few tenths down. So I wonder, there's no way of recalibrating it so it works right. 0.4, 0.5, all of them are going to be up 2/10. Where's the ½ inch? Here. There should be a ½ inch plus 2. Yeah, it's consistently low by about a ½ thou. Okay, and there's no way I can compensate for that, right? Yeah, because I'd have to go down further and zero it. I could try using the fine tune to set it right, and then it would be measuring right, but... And what did I say? Okay, I was supposed to grab this guy, which is, this is 0.1004, which when mic'd is 0.10055. So this should read a ½ thou up. Wow, 0.1003. That's pretty darn close right now. And if I go sideways, the nice thing is this guy doesn't really move because of play in the stem. So it's off a little bit. Works, kind of works. To check the digitals on this, or rather the analog needle ones, I could change out the back or unscrew it and see what happens, but very nice stand. I like this for setting cutting tool heights, and who knows what's going to come up in the future. But on this indicator, I think it would have been better to buy the one that only shows a tenth, not this many digits, which is cheaper. This was like $45. The other one's $25. I wish I would have bought the other one, because you don't need this kind of craziness for accuracy. Well, I tell you, the stand definitely holds everything solid. The camera's in direct alignment, so it looks like the needle's on 0. I can see why you need the fine adjusts. All I could do was just basically put it close and then spin the dial to put it on the 0. But let's see what this guy comes in at. 0.1 here is the right one. 0.1 is 0.10015. Can you see a tenth on this guy? Yep, you sure can. So I was pretty impressed before with this indicator, even though it was on the other arm. 0.2 is 0.20015. Boy, I love the smoothness of this granite block. Yep, no, it's on 0, so it's not going to show the 1.5. And 0.3 is 0.3002. You're going to show me the 0.2. Nope, it's looking low. So I think this indicator is probably safe to say it's within a half a thou. Is that still on 0? Yeah, it's still a return. Stand is beautiful. 0.4 is 0.40025. See where you're going to come in at. Yep. So I think it's actually less than a half a thou off. So pretty good. I'm very, very impressed with it. So if you really want to start playing with tenths or testing your indicator, you definitely need, ooh, you can move it. You definitely need a comparator stand. It's the only way you're going to stay solid. Because look at that. But yet, it zeroes out. I wonder if it didn't show because it tilted. Interesting. I doubt it, because there's not that much force here on this at all. So that's kind of my conclusions here. Just wanted to make sure that the indicator is what's showing error rather than this pole moving. So the tutorial's up here. Each little tick is 1/10 of a thousandth of an inch. I'm close to the top on the pole where you're most likely going to see the pole bend. So if I lift this guy up, you don't see any movement in the test indicator. That pole is rock solid. This whole setup's beautiful because it keeps coming right back to 0 again. I love this whole thing. Is that moving? I don't think so, but I'll know for sure in the video. So the error is definitely in this guy. The digital looks like more playing I did with it. It's off by 2/10. It's always 2/10 low. This guy is also low by a little bit, so pretty neat. Just doing some more messing around here. Camera's between me and the dial indicator, but I was just for fun through some of these feeler gauges, thickness gauges under there, and then the readings were way off, so I mic'd them, and yeah, real cheap set. Forgot where I picked this up, like a long time ago. The 23,000s came in 24.5 after I mic'd it. So, but so yeah, if you can't afford the big granite block and an indicator arm and so on to set up, this is well worth it. But it was also, here's a stare it. Thickness gauge, feeler gauge, it's a half a thou, and it's just paper thin if I can get it out of here. Way too fast. Jeez, get it back in the envelope some. But I had played with this just to stick it under there, and boom, half a thou, right on the money. Sorry about the reflections, just I got tired of it. So eventually when I build a different stand, a holder like the Noga, to drop it in, I'm gonna use the digital only. But then I was thinking, hey, wait a minute, let me check out and see just how flat this guy is. Wow, that's really pushing it up there. Alright, so not too bad, huh? Jeez. I'll have to see if that needle is moving here when I do the video. I think it is. Yeah, it looks like it's moving almost a half a thou. So I was wondering too, the 1, 2, 3 block, how good is it? Let me wipe it off here. Yeah, I should be able to get that under there, right? Boy, this is really pushing the height there. Ooh, on 0, how nice. So some of that can be just the play that's in there. This is a pretty good block. So if you don't have gauge pins or gauge blocks, you don't really need them. Use few thickness gauges, anything you have, just mic it. You know what the size of it is, stick it under there, and you can easily check out your dial indicators to see how accurate or inaccurate they are.